This resource considers the binomial distribution. We define the situation to which this distribution applies. We discover how to find the probability of having some number of successful trials. We then go through several examples. Consider an activity that only has two possible outcomes. One of these outcomes is considered a success, the other is a failure. Now suppose we do that activity multiple times. These types of situations are binomial experiments. The binomial distribution allows us to find the probability that in some number of attempts, we get a specified number of successes. For example, if we flip a coin several times, what is the probability of getting some number that land heads up? Or if a baseball player has some number of at-bats, what is the probability they get some specified number of hits? Or if we roll a pair of dice several times, what is the probability of getting a particular roll, like snake eyes, double ones, some number of times? Now that we have an understanding of what the binomial distribution is used for, how do we actually find these probabilities? Suppose we have a situation that can be described using a binomial distribution. We have a number of variables to define before we can look at the formula. We call the probability of success on any trial P, and the probability of failure is Q, which can always be found by subtracting P from 1. We have some finite number of trials, which we call N. We look to have K number of successes. Our variable that represents how many successes actually achieved, we will call X. With these definitions, the formula to find the probability that we have K number of successful trials is N choose K multiplied by P raised to the K power multiplied by Q raised to the power N minus K. Let's look at some examples. Suppose Jamie flips a coin 15 times. What is the probability they have 7 of those tosses land heads up? Because flipping a coin only has 2 possible outcomes, this is a situation for which we can use a binomial distribution. In particular, we are considering landing heads a success, so tails would be a failure. We have 15 flips, so that is our N, and we want 7 heads, which will be our K. The probability of success is 1/2, or 0.5. The probability of failure is 1 minus the probability of success, so Q will also be 0.5. Now that we have all our definitions, we can find our probability. Plugging into our formula, the probability of 7 heads out of 15 flips will be 15 choose 7 multiplied by 0.5 raised to the 7th power times 0.5 raised to the quantity 15 minus 7. Doing these calculations, we find that our probability is approximately 0.1964, or nearly 20%. Ronnie Baseball is a baseball player that has a batting average of 300. What is the probability that he lives up to his average and gets 3 hits out of his next 10 at-bats? Because the player either gets a hit or he doesn't, this is another example of a binomial distribution. We have 10 trials, which are the at-bats, and we want to have exactly 3 successes, or the 3 hits. The probability of success is 0.3, since that is his batting average. The probability of failure is 1 minus the probability of success, so we have a value of 0.7 for our Q. Plugging these values into the binomial distribution formula, we have that the probability of getting exactly 3 hits out of the next 10 at-bats is 10 choose 3 multiplied by 0.3 raised to the third power, multiplied by 0.7 raised to the quantity 10 minus 3. Completing these calculations, Ronnie has a probability of 0.2668, or just over 25%, of getting 3 hits in his next 10 at-bats. Suppose Ronnie Baseball, with his .300 batting average, has a clause in his contract that he receives a $1 million bonus if he has a total of 200 hits in a season. So far in the season, Ronnie has amassed 194 hits. However, there are only 2 games remaining in the year. Ronnie figures he will have 8 more at-bats in those 2 games. What is the probability he will get enough hits to trigger the bonus payment? Ronnie needs at least 6 more hits in those 8 at-bats. As before, his probability of success is 0.3, and the probability of failure is 0.7. Unlike the previous example, there are multiple methods for Ronnie to receive his bonus. He needs at least 6 hits. To find the probability Ronnie gets his bonus, we need to add together the probabilities Ronnie gets 6 hits, or 7 hits, or 8 hits out of those 8 at-bats. First, let's find the probability Ronnie gets exactly 6 hits in 8 at-bats. We plug into the formula, and we find the probability is 0.010019. Now we will find the probability Ronnie gets exactly 7 hits in the 8 at-bats. Plug into the formula. The probability is 0.001224. We plug into the formula to find the probability of getting exactly 8 successes out of 8 trials. We find this probability is 0.000066. To find the probability Ronnie gets his bonus, we add the probability of 6 successes out of 8 trials, plus the probability of 7 successes out of 8 trials, plus the probability of 8 successes out of 8 trials. So overall, Ronnie Baseball has a probability of 0.011309, or slightly over a 1% chance of triggering his bonus payment. Hopefully, Ronnie doesn't have any real need for those funds, because it is not likely he will get the bonus.